Welcome to qnawire.
Here, we define the velocity of a satellite going around a planet, given that we know the radius and velocity for a different satellite. So, as in all satellite problems, the first thing that we need to realize is that our centripetal force, mv squared over r, is given by the gravitational force. So that's m times the mass of the planet, which I'll call mp, times the gravitational constant over r squared. So if we want to find v for any satellite, we can just write that that is equal to m of our planet times g over r. Now, in this case, for our first satellite, we know both quantities needed to solve this problem, but only one for the second. So the way that we're going to solve this is to set up a ratio. So we can write that v2 over v1 is equal to, let's set up our square roots, g times the mass of the planet over r2 over the square root of g times the mass of that same planet over r1. Now, all the constants in this problem are going to cancel out, and that'll give us, when we simplify, that this is equal to the square root of r1 over the square root of r2. So, since our goal in this problem is to solve for v2, we can rearrange. And now all that's left to do is plug in our numbers and solve. So if we go back to the first page to check our numbers, r1 is 2.25 times 10 to the 6 meters, square root that, over r2, 8.6 times 10 to the 6 meters, square root that, and both of those are going to be multiplied by v1, 2.25. Draw an arrow, make room down here. 2.25 times 10 to the 6. And even though it's a little bit messy, when we plug in all our numbers, we get that our answer is equal to 1.33 times 10 to the 4 meters per second. And that's the answer to this.